Now, good day everyone. So it's your favorite math and physics tutor here again. So we are here with another topic, which is motion. Now, motion is a very popular topic in physics. All right, and I would love to explain this in a way that we can easily understand, and then we'll take some calculation questions. So let's go straight down into the video. What is motion? I'm sure we must have heard of this word before, alright? But let's bring it in context or in the field of physics now. Now, motion doesn't just have to deal with movement. In physics, motion is the study, or motion is the change of the position of a body with respect to time. Motion is the change of the position of the body with respect to time. So you can see the difference between motion being explained outside physics and being explained in physics. So generally, motion is usually regarded as being a movement, all right? Maybe just moving from one place to another. But when you bring it in the field of physics, it goes beyond that, all right? Motion is the change of position, right? That's movement, all right? Calculated with respect to time. So motion is not just movement. Motion is movement with time in physics, all right? So please take note of that. Now, there are some keywords we need to take note of when we are studying motion. So some terminologies. One, we need to know what distance is. So I'll explain each of these one after the other as I go. Now, distance simply means space traveled. It means space or length traveled, alright? So it means space traveled. So for instance, I can move from point A to point B. I can walk a distance of 2 kilometers. So this is an example of a distance, alright? Covering a space or traveling a space. So I traveled the space in between A to B. So that is what distance is. So distance simply is the measure of space or space travel. Okay, the next terminology we'll look at, or before we go into that, the reason why I touched on distance is because distance has a lot to do with motion, because it deals with movement. For you to cover a distance or for you to travel a distance, you must move, meaning motion has to take place. So that's why we are looking at this. We are looking at some of the applications of motion and some of the terminologies motion comes with. So we are looking at distance because distance, alright, to cover a distance you need motion or you need to move. Another terminology is displacement. Displacement. Now, displacement is oftentimes interchanged with distance, or most times students think it is the same thing. Now, please, displacement and distance are not the same. Even though they are very much related, they are not the same. And this is what I mean. Distance simply is the measure of space, or is the space traveled, but there is no direction to distance. Alright, say for instance, you can see here, I just wrote down 2 kilometers. 2 kilometers can be in any direction. Alright, 2 kilometers can be in the northward direction, can be in the southward direction, can be in the westward. So it is not really specific, right? So that's what distance means. But when it comes to displacement is a vector quantity, and it tells us the direction at which a body is headed. For instance, I can say I traveled from A to B westward. I traveled 2 kilometers west. So if I start from A, so to draw this diagram, this is how it looks like. Alright, why am I drawing the arrowhead in this direction? Why didn't I draw the arrowhead here? Because the direction was specified, because I started from here and then I moved in the westward direction. So this is displacement. Displacement direction is always specified. So please take note of that. Although they are calculated using the same unit or they are measured in the same unit, but that doesn't make them equal to each other. Alright? So the next terminology we want to look at is speed. What is speed? What is speed? Speed is the distance covered per time. It's the total distance covered per time. It is the total distance covered per time. So speed simply calculates the total distance covered in 1 second, 1 hour, or it depends on the time measurement you are using. So for instance, if I say a car travels with a speed of 20 kilometers per hour. So what I'm simply saying in this instance is that this car can travel 20 kilometers in just 1 hour. So this is what speed means. So speed tells us rather the distance covered or the distance you can cover in 1 hour or in 1 second, depending on the time, the unit of measurement of time you are using, right? So that is what it means. Now, another thing you need to know about speed is just like distance, but direction is not specified. It is not specified. So if I were to tell you that a bus is moving at a speed of 20 kilometers per hour. Now, 20 kilometers per hour can be in any direction. Can be in the northward direction, in the southward direction, in the eastward, westward. So it is not really specific. So this kind of quantity is called a scalar quantity. Why? Because direction is not specified. Now, if you want a full video where I talked about scalar and vector quantities, I've made that video. Alright, and please make sure you continue to subscribe to Abbey TV, alright, where you will learn a lot. You would learn a lot on math and physics. So thank you. Now, let's come back to what we're saying. So I said 20 kilometers per hour. It is a scalar quantity. Why? Because direction is not specified. Beautiful. Now that we've established that, let's move on to the next terminology, which is velocity. Velocity. What is velocity? Velocity simply is used interchangeably with what? Is speed, but they don't mean the same thing. They are different, just like how you have distance and displacement, alright? They are different. So what is velocity? Velocity is the displacement covered per time. Remember I said speed is the distance or total distance covered per time, right? While velocity is the displacement. So you can see the discrepancies between the two, or the difference there. So in velocity, in speed you are dealing with distance. In velocity you are dealing with what? Displacement. So this simply tells you something, that in velocity direction is specified. In velocity direction is always specified. So please take note of that. So I can say, for instance, a car moves with a velocity of 20 meters per second, or let me use 20 kilometers per hour, west or east. Why is this velocity? Because direction is what? Is specified. So please take note of this. Distance is a scalar quantity, displacement is a vector quantity, speed is a scalar quantity, and then velocity is a vector quantity. Alright? So now quickly let's see acceleration. Acceleration. What is acceleration? What is acceleration? Now, acceleration is the change in velocity per time. It's the change in velocity per time. Now, take note of this definition because it is very important. Now, acceleration simply calculates how fast the velocity of a body is changing. Did you get what I just said? I said acceleration calculates or tells us how fast the velocity of a body is changing. So if I were to tell you something like a car has an acceleration of 20 kilometers per hour per hour. Now, this simply tells you that, remember we said acceleration is the change of what? Or change in velocity per what? Unit time. So this tells you that if a car has a velocity of an acceleration of 20 km per hour, what that simply means is that the velocity of that car changes in 20 minutes. So this simply means If the starts from rest, that is 0 km per hour. So it quickly switches from 0 towards 20 km per hour. In how many hours? In 1 hour. So it changes velocity in 1 hour. So the next velocity you're going to see there is what? 40. Because it is changing by what? 20, right? It is changing by 20. So because the acceleration is 20 km per hour, you are still going to you keep on adding 40 and 20, 20. So let me draw a table so you can get the idea. So if you have something like this, we'll call this time, we'll call this velocity. So in the 0th, when it was at rest, alright, it had no velocity. The next 1 hour, it had 20 km. The next hour, 40. The next 60, like that. So this is in kilometer per hour. This is in hours. So this here will be 8. So this simply tells you that when it increased from 0 to 1, meaning when it added 1 more hour, it increased by 20. So the velocity is changing by, so it was in 0 km per hour, moved to 20 to 40 to 60. So you can see that there's actually a common difference, alright, adding up. So that is what acceleration is all about. So acceleration simply is the change in velocity by time. Establish each of these concepts. I will know what they mean, each of these terminologies, right? And we know what acceleration is, distance is. Now I want to quickly look at a subtopic which is called equation of uniformly accelerated motion. Now, the equation of uniformly accelerated motion, there are some equations guiding the measurement or how we can calculate or get the acceleration of a body, the distance, the displacement, whatever case it may be, alright? There are some equations rather that can help us to get the values of these things, alright? And I'm going to take them one after the other. There are about 3 of them. I'm sure that most of us are familiar with them, but I'm going to show you how it was gotten, alright? So the first equation I'm going to show to us is, now velocity, like we said velocity is the displacement of a body per unit time. The displacement of the body per time, unit time, or the change in displacement, the change in distance or displacement of a body per unit time. So let's go. We say velocity, which is v, is equal to displacement over time. Velocity is equal to displacement over time. So most times it's usually written as v is equal to s over t. S usually is used to represent displacement or height or distance. Now, acceleration on the other hand is what? The change in velocity per time. Remember we established that, right? Good, beautiful. Now, in motion, whenever it comes to vector quantities, right? There is usually vector quantities most times take a negative sign. They can either be negative or positive. And I will explain why that is. Because, like, take for instance now, displacement is a vector quantity. Now, we can have initial distance, we can have final distance. Yes, to get the displacement of a body that travels its initial distance and also travels its final distance, what you just do is to calculate the displacement. It will be final distance, which is d2 minus d1, which is the initial distance. So that tells you that displacement can either be negative or positive. Please take note, most vector quantities are either negative or positive. Alright? Now, so the same goes for acceleration. Now, right? Because acceleration, a body can change velocity in 2 ways. Alright? You can either change in form of an increase or you can change in form of a decrease. So a body can move from 30 meters per second or 30 kilometers per hour, move down to 20 kilometers per hour. That is a change in velocity, but that form of change is a decrease. Alright? So what I'm trying to establish to you or tell you is that acceleration can either be negative or positive. So change in velocity, we simply say v minus u over t. And what is v minus u? V is final velocity, u is initial velocity. V is final velocity and U is initial velocity. So this simply means to get the change in velocity, what do we need to do? To be V minus U, that's the change in velocity, over time. So that's the formula for calculating acceleration, which leads us to the first equation of motion, which states, or which is, acceleration is equal to V minus U over T. So once you cross multiply this is A times T, that's AT, and this is V minus U. And then when you make V subject of formula, you have V to be equal to when you make V subject of formula, you have V to be equal to U plus AT. So this is equation 1. Thank you so much for watching. We'll have to stop here for today. So we're going to continue in our next class. We have a lot to cover, a lot under motion. We've not even started any calculation aspect. We have a lot to cover. Thank you so much for staying to the end. Please, if you have not subscribed to Abe TV, please make sure you do that now. Abe TV is a platform or a channel where you learn everything basically, all right? From different subjects, biology, it covers subjects in science, covers subjects in commercial, covers subjects in arts, alright? So please make sure you do help to subscribe so you can be notified whenever we upload a new video. Thank you so much and see you in the next class.